Dear students, this is lecture 3 of alcohols and phenols. I am Dr BRAJA Bandhu Nanda. In this class, I shall teach you the properties of alcohols. In this heading, we shall discuss about the physical properties, chemical properties, reactions involving the cleavage of a OH bond, reaction involving the cleavage of a ROH bond. First, let us discuss about the physical properties of alcohol. So, in this heading, we shall discuss about the boiling point of alcohols. Dear students, alcohols generally have a higher boiling point in comparison to other hydrocarbons having equal molecular masses. This is due to the presence of intermolecular hydrogen bonding between hydroxyl group of alcohol molecules. Boiling point of alcohols increases with an increase in the number of carbon atoms in the aliphatic carbon chain. The boiling point decreases with the increase in branching in aliphatic carbon chain. The van der Waals force decreases with a decrease in surface area. Thus, primary alcohols have a higher boiling point. I am just giving you some example where the table contains the boiling point of some short chain alcohols. I am giving you first example methanol CH3OH whose boiling point is 65. The second example is ethanol C2H5OH whose boiling point is 78 degrees centigrade. So what we observed? We observed that the boiling point is increased with the increase in the number of carbon atoms. Similarly, right side 1 propanol. So there are 3 carbon atoms C3H7OH. So its boiling point is 97, still is increased. 1 butanol C4H9OH, the boiling point is 117 degrees centigrade. So 117 degrees centigrade. That implies that with increase in the number of carbon atoms, the boiling point of the alcohol molecules increases. Let us come to the solubility of alcohols. The solubility of alcohol in water is governed by the hydroxyl group present. The hydroxyl group in alcohol is involved in the formation of intermolecular hydrogen bonding. Thus, hydrogen bonds are formed between water and alcohol molecules which make alcohol soluble in water. The alkyl group attached to the hydroxyl group is hydrophobic in nature. Thus, the solubility of alcohol decreases with the increase in the size of the alkyl group. Just I am giving you the hydrogen bonding, how it is shown in case of alcohol molecules. So, in ROH, you see the alkyl group is the hydrogen atom is also bonded with another alcohol molecule with a dotted line. This dotted line indicates this is the hydrogen bond. So this is intermolecular hydrogen bonding in alcohol. If you take one water molecule and one alcohol in the right hand side, you see ROH is the alcohol, HOH is the water molecule. The partial negative charge is developed on oxygen and partial positive charge on hydrogen. Similarly, in case of oxygen, same thing happened. So, the partial positive charge of hydrogen of alcohol bonded with the partial negative charge of oxygen of water. So, as a result, a hydrogen bond is formed which is known as intermolecular hydrogen bonding between alcohol and water. Due to this reason, alcohols are soluble in water. Number 2, when the alkyl chain is increased, listen, in case of alcohol, R is here. If alkyl chain is increased, which is the hydrophobic in nature, hydrophobic means it will not like water molecules. Therefore, it decreases the solubility of alcohol in water. So, with increase the length of alkyl chain, the solubility decreases. And I am just showing you some examples here. Methanol, and whose solubility in water per gram per 100 gram. If you take 1 gram of methanol and which will be dissolved in 100 gram of water, then what will happen? Then it is infinitely soluble. That means it is soluble at any extent. If you take ethanol, then also it is infinitely soluble, infinitely soluble. If you take propanol, it is also infinitely soluble. But if you take butanol, then the 9 gram of butanol will be dissolved in 100 gram of water. Similarly, in case of a pentanol, so it decreases. Why? Because the alkyl chain increased. So 2.7 gram of butanol, a pentanol will dissolve in 100 gram of water. In case of hexanol, 0.6 gram. In case of heptanol, it is 0.180 gram. In case of octanol, it is 0.054 gram. But if you take decanol, which is insoluble in water, because it has very large alkyl nature, so which is very, very hydrophobic. So come to acidity of alcohols. Alcohols react with active metals such as sodium, potassium, etc. to form the corresponding alkoxide. These reactions of alcohol indicate their acidic nature. The acidic nature of alcohol is due to the polarity of a OH bond. The acidity of alcohols decreases when the electron donating group is attached to the alkyl group as it increases the electron density on the oxygen atom. Thus, primary alcohols are generally more acidic than secondary and tertiary alcohol. We know that the alcohol is less acidic than water. Why? Because the H plus ion concentration or the Kw, ionic product of water, is equal to 10 to the power minus 14, whereas the Ka of alcohol is 10 to the power minus 18. Therefore, it is less acidic than water. So, chemical properties of alcohols. Students, there are different chemical properties. So out of this, we have to first discuss as nucleophile, how it behaves as one of the nucleophiles. The electron pair on the oxygen atom can be donated to a positive species. Alcohols therefore act as a nucleophile. Just I am showing you the example. In the left hand side, ROH is there. So there are two lone pair of electrons present on the oxygen atom. One lone pair on the above oxygen and another lone pair on below. And here C plus is there. Why C plus? If some compounds having carbocation, then it will be C plus. Then this oxygen will donate its electron pair to this carbocation. As a result, the bond is formed, which is shown at the right hand side. You see ROH, single bond C dash dash dash. So here OH bond is positive because it has donated one electron. Therefore, OH bond becomes positive. Since it is unstable, so therefore it loses the H as H plus ion to form RO single bond C plus H plus. So I am just giving you one example. The reaction of alcohol with acid chloride. In acid chloride, the carbonyl group is polar because the C double bond O group is present and the oxygen atom is more electronegative and carbon atom is electropositive. Therefore, the oxygen atom of ethanol will share its electron pair with the carbon atom of ethanoyl chloride to form a bond as given at the right hand side. CH3CO minus and Cl and OC2H5H. Then after the rearrangement of the electrons, that means the oxygen atom has negative charge, so that negative charge will come to oxygen in the form of an electron and forms a double bond, and at the same time the Cl atom of which is attached to carbon, now middle carbon, it will removed in the form of a HCl. So what will be formed? CH3 C double bond O C2H5, that is ethyl ethanoate. It is an ester. So acid chloride on reaction with alcohol in presence of a pyridine gives an ester. This is one of the so in this reaction, alcohols act as nucleophiles. It can also act as one electrophile. So all of you know that electrophile are the substances which are electron loving. Electrophile means electron loving. So when alcohols are protonated, they act as electrophiles. For example, RCH2OH H plus. So here what happens? The H plus will come to oxygen. When H plus will come to oxygen, then it becomes protonated alcohol. It becomes RCH2OHH. So if one Cl minus will come, Cl minus means it's electron rich species, that is electron rich means it will attracted towards the protonated alcohol. So protonated alcohol will attract this electron pair to form a compound like RCH2OHH plus and a Cl. What will happen? Cl CH2R plus water. So here alcohol in presence of H plus ion is converted to alkyl halide. So that is the electrophile. So let us come to the example. When ethanol reacts with HCl in presence of anhydrous zinc chloride. So I am not writing here anhydrous zinc chloride because I want to show you how it behaves like as an electrophile. C2H5OH plus H plus, it will convert it to protonated ethanol C2H5OHH, positive charge on oxygen atom because it has shared its lone pair of electron with H plus. So if it will be reacted with Br minus, then what will happen? The Br minus will act in the form of a SN2 reaction, nucleophilic substitution reaction. It will attack to the ethyl group and OH2 will be removed in the form of a water. It is given here, and a ethyl bromide plus water is produced. Out of the other chemical properties which are involved in this, which the alcohols, are a reaction involving the cleavage of a OH bond, reaction involving the cleavage of a dash OH bond, reactions involving R and OH group. Students, in this class, we shall only discuss about the reactions involving in the cleavage of OH bond and the reactions involving in the cleavage of dash OH bond. First, the reactions involving the cleavage of OH bond. Students, you see the below alcohols where methyl alcohol and any primary alcohol, secondary alcohol, tertiary alcohol is given. Which bond will be cleavage? OH bond. That means we shall prove it is acidic because OH, when a substance will give H plus ion, then it becomes an acid. So if OH bond will be broken, then it becomes an acid. So out of these four compounds, in which case the OH bond will be broken easily? Let us discuss. Students, if OH bond will be broken, the oxygen atom becomes negative and the hydrogen atom becomes positive. So in order to make the ion stable, if another group is present along with oxygen which can withdraw electron, then it becomes more stable. If the groups attached to oxygen donates electron, then it becomes unstable. So in case of a tertiary alcohols, there are three alkyl groups attached to the carbon which is attached to oxygen. Therefore, alkyl groups are electron donating. You know that oxygen becomes minus charge. So electron donating groups will be increased. So therefore, it becomes most unstable. Most unstable. Let us come to the left hand side, which is secondary alcohol. Secondary alcohol contains two alkyl groups, two electron donating groups, plus I effect groups, which is attached to carbon, then carbon is attached to oxygen. So you know that if negative charge is present on oxygen, further other negative charges are going from the alkyl group. So it becomes unstable. So it is less unstable than tertiary alcohol. Similarly, the primary alcohol is less unstable than secondary alcohol, and methyl alcohol is stable because it is not attached to any alkyl groups, or comparatively it is more stable. So if we'll go for the reaction rate or the relative reactivity, so which will be more reactive? Which will be more reactive? The more, in general order, the reactivity of alcohols towards this type of reaction is methyl alcohol is more reactive than as primary alcohol, then it is more reactive than secondary alcohol, it is more reactive than tertiary alcohol, because the most stable ion will be more reactive. In this reaction involving the cleavage of OH bond, again I am explaining, the oxygen atom is to take off the electron pair from the bond. The presence of the alkyl group with the plus I effect tend to increase the electron density around oxygen atom. Consequently, the bond cleavage in OH bond becomes difficult. We can also say that the alkyl group decreases the polarity of OH bond, thereby making the release of H plus difficult. This adversely affects the reactivity of alcohol. Greater the number of alkyl groups present in alcohol, lesser will be the reactivity. Few chemical reactions involving the cleavage of OH bond are given below. First is the acidic nature. Students, alcohol react with sodium to form sodium alkoxide plus hydrogen. So this is the nature of one acid. So in case of ethyl alcohol plus sodium, it will give sodium ethoxide plus hydrogen gas. The order of reactivity of acidic strength of alcohol is primary alcohol is more reactive, more acidic than secondary alcohol than tertiary alcohols. Then the reaction with the metal hydrides. So metal hydrides are strong bases and form alkoxide with alcohol, because you know that alcohol is acid and we have to react with a base. So metal hydrides are base. So acid plus base is equal to salt plus water. So ROH plus MH, M plus H minus, because it is a base. So what happened? The H of alcohol will be replaced by M. So what happens? Metal alkoxide plus hydrogen, ROM plus H2. So in example, ethanol plus NaOH, sodium hydride, what happens? So sodium ethoxide plus H2. So reaction with Grignard's reagent RMgX or alkyl magnesium halide. Alcohols react with Grignard's reagent to give alkoxide salt and alkanes. Let us see ROH plus RMgX. So H of alcohol and R of Grignard's reagent, they combine together to form RH. RH means what? Alkane. So ROMgX, the rest product will be formed. So here the ethanol I am taking the example plus methyl magnesium bromide. So H of ethanol and a CH3 of methyl magnesium bromide combine together to form CH4, and a C2H5 OMGBr is the side product. So methane is the main product which is formed during the reaction of methyl magnesium bromide. And the fourth one is the reaction with the organic acids or formation of esters. So, in this reaction, the carboxylic acids react with the alcohol in the presence of a concentrated sulfuric acid to form a molecule of ester and water. You see, so RC double bond OOH, this is an carboxylic acid plus ROH, the alcohol. So, OH of a carboxylic acid and H of alcohol combined together in presence of a acid, sulfuric acid, it gives RC double bond OR plus water. So OR means is a ester. So take some example. So acetic acid plus ethyl alcohol. So CH3C double bond OH plus HOC2H5. So OH of acetic acid and H of ethyl alcohol, they combine together to form water, and the OC2H5 will attach to C double bond O. So what will the compound? CH3 C double bond O OC2H5 plus water. So this becomes ethyl acetate plus water. Similarly, if you take a benzoic acid, C6H5, C double bond OH, this is the benzoic acid. When a benzoic acid also react with ethyl alcohol, what happens? The OH of benzoic acid and H of ethyl alcohol, it will be removed in the form of water. So what will form? C2H5, C double bond O, C2H5, which is ethyl benzoate is produced. Students, this reaction is of a reversible nature, and the reverse reaction is known as ester hydrolysis. H2SO4 is a dehydrating agent and absorbs water formed in the reaction. As a result, the reaction proceeds in the forward direction, and this facilitates the formation of ester. Therefore, these reactions are taking place in presence of a sulfuric acid. You remember, in absence of sulfuric acid, the reaction becomes reversible, and instead of getting ester, the ester will react with water to form acid and alcohol. That is another reaction, the formation of acid. So, relative reactivity of alcohol on acids. As expected, the relative reactivity of alcohol in the esterification reaction is primary alcohols are more reactive, all of you know that. So CH3OH is greater than CH3CH2H is greater than CH3 whole twice CH, that means isopropyl alcohol is greater than tertiary butyl alcohol. So which acid will react? The reactivity of acids is related to the acid strength and follows the order. Formic acid is more reactive because formic acid is more acidic than acetic acid, which is more acidic than butyric acid. Similarly, it is the valeric acid. So you see, if the acid is stronger and the reactivity also more. Let us come to the mechanism of esterification. The mechanism involves the nucleophile attack of ROH on protonated carboxylic acid as follows. Students, carboxylic acid is RC double bond OH. This C double bond O of a carboxylic acid will protonated with H plus ion to form RC double bond OH plus OH. The double bond OH plus is, you know, that unstable. Therefore, when a positive charge is reside on oxygen atom, it becomes unstable. Therefore, it will take up the electron from the double bond to form Rc plus OH. You know that the positive ion present in the carbon is known as carbocation, which again react with the ROH. So it is a nucleophilic attack. So the electron pair on ROH will come to the C plus ion. So what happens? RCOH, OH, single bond, OHR. You see, the H of ROH will go to OH of acid, and it is called H plus ion shift. So what will happen? RCOH OR and OH2 plus. OH2 plus means unstable. So the lone pair electron of OH will come down to carbon, and the OH2 plus will be broken in the form of water. So it will formed minus water. So RC double bond OH plus OR. Students, since it is OH plus, so it becomes unstable. So it will lose one H plus ion to form R C double bond O OR. So this is an ester. So this is the mechanism of the esterification. And another reaction with acid chlorides or acid anhydride, which is known as acylation. When an alcohol is reacted with acid chloride or acid anhydride, the hydrogen atom of OH group gets replaced by acyl group RCO to form ester as the main product. The reaction is known as acylation. I am just giving you example. CH3COCl, this is called ethanoyl chloride. It will react with ethanol C2H5OH. Reversely I have written. So Cl of ethanoyl chloride and H of ethanol, they go out in the form of HCl, and what will happen? The C double bond O group will attach to OC2H5. As a result, ethyl ethanoate is formed. This is an ester. So come to ethanoic anhydride when react with ethanol. So here instead of a Cl, here O C double bond O CH3 will be replaced by O C2H5. So what will happen? So ethyl ethanoate will be formed plus acetic acid will be formed. So the second reactions involving cleavage of a R single bond OH bond. So in case of this reaction, the reactivity order of different alcohol is methyl alcohol is less reactive than primary alcohol, is less reactive than secondary alcohol, is less reactive than tertiary alcohol. Students, it is reverse than the reaction taking place in case 1, OH, O dash H bond cleavage. Here R dash OH bond cleavage. What happened? Let us see. We know that the alkyl group has a plus I effect. It increases the electron density towards the carbon atom as well as the oxygen atom of a COH bond. As a result, the bond cleavage becomes easy. Greater the number of alkyl groups present, more will be reactivity of alcohol. Thus, the reactivity order the relative order of reactivity of the alcohols is justified. The reactions involving the cleavage of a COH bond are as follows. Reactions with hydrogen acids, reactions with phosphorus halides, reactions with thionyl chloride. Students, reactions with halogen acids or preparation of a monohaloalkanes. Students, alkyl chlorides can be prepared by heating alcohols with a mixture of HCl and anhydrous ZnCl2, that is Lucas reagent. This process is called Group's process. I have already told you in alkyl halide chapter. Here ROH plus HX gives rise to RX plus water. Here OH is directly broken. You see, I have just given you by giving bracket. Here OH of alcohol and H of acid will combine together to give water, and RX combine to give alkyl halide. The alcohol relative reactivity order 3 degree greater than 2 degree greater than 1 degree greater than methyl. What I have already told you. Hydrogen halides reactivity order. So HI will be greater than HCl, which is greater than HBr, greater than HCl and HF. I am just giving you example. CH3CH2OH plus HCl in presence of anhydrous ZnCl2, the OH will be replaced by ACl and ethyl chloride plus water. I am just giving ethyl alcohol plus HCl anhydrous ZnCl2. is ethyl chloride. So, propan-2-ol or isopropyl alcohol when react with HCl, then anhydrous ZnCl2 to give 2-chloropropane or isopropyl chloride plus water. Similarly, tertiary butyl alcohol react with HCl where no anhydrous zinc chloride is required. Okay, why? Because this is more reactive. 3-degree alcohol is more reactive, so no catalyst is needed here. So ZnCl2 is a Lewis acid since Zn is electron deficient. This coordinates with the oxygen atom of OH and weakens the COH bond. This helps in the bond cleavage leading to substitution by chlorine atom. Just I am giving you the structure. ROH plus ZnCl2. So the electron pair of oxygen atom will go to ZnCl2 because it is electron deficient. What formed? ROH single bond ZnCl2. Here Zn minus and O plus. So it is the bond is broken between R and O because it is weakens this RO bond. So it becomes R plus O HO ZnCl2 minus. R plus Cl minus, which is formed from alkyl from HCl, it will give RCl. Okay, since the carbocation is formed here, so greater the stability of a carbocation, greater will be the reactivity. You know that the 3-degree carbocation is more stable than 2-degree and 1-degree due to the plus I effect of alkyl groups. Therefore, 3-degree alcohols are more reactive. Then alkyl bromides are prepared by refluxing a suitable alcohol with HBr. As the acid does not exist as such, it is prepared in the formation of a mixture itself by heating NaBr with concentrated H2SO4. NaBr plus H2SO4 gives rise to NaHSO4 plus HBr. ROH plus HBr gives rise to RBr plus water. HBr is not directly formed. Therefore, it is prepared by reacting NaBr with H2SO4. Similarly, alkyl iodides are prepared in the same way. Ki plus H3PO4 gives rise to KH2PO4 plus Hi. Then ROH plus Hi gives rise to Ri plus water. Then by the action of phosphorus halides, alkyl chlorides can be formed by reacting the PCl3 or PCl5 with alcohol. You see CH3CH2OH plus PCl3, CH3CH2Cl plus H3PO3, or ethyl alcohol plus PCl5 gives rise to ethyl chloride plus POCl3 plus HCl. Alkyl bromides can be prepared by heating alcohol with red phosphorus or bromine and bromine. Okay, so P4 plus Br2 gives rise to PBr3. Then alcohol plus PBr3 gives rise to ethyl bromide plus H3PO3. PBr5 does not exist, therefore it will not react with this compound. Alkyl iodides can be prepared by heating ROH with red phosphorus and iodine. P4 plus 6I2 gives rise to 4Pi3. That Pi3 will react with ethanol to give ethyl iodide plus H3PO3. By the action of a thionyl chloride, students, alcohol can react with thionyl chloride to give alkyl chloride. Okay, this is the purest form. I am just giving you example. ROH plus SOCl2 in presence of pyridine, it will give RCl plus HCl plus SO2. It is a purest alkyl chloride because the byproducts like HCl and SO2 are gases. SOBr2 and SOI2 are not used because SOBr2 is unstable and SOI2 does not exist. Thank you, students.